So looking at our aim for today, we're going to be adding and subtracting positive and negative decimals. So we've done fractions, we've done whole numbers, we've done mixed numbers, we've done all that stuff. So the last part of our operations unit revolves around dealing with decimals. Sounds like a good movie, dealing with decimals. So the thing that I just want to open this up with, looking at this first particular problem. This is a word problem, and this is a common problem when it comes to engineering. When you're designing things, you often think about how things fit together. So in this particular instance, and this was still is a real instance of something that is going on in my household. I have a copper tube that is a diameter of 0.56 inches and a wooden dowel rod that has a diameter of 0.632 inches. The dowel rod is supposed to fit inside the copper tube. How much bigger is the tube? So if you want to find out how much bigger something is, you should be subtracting from that. So you look at this number in 0.56 minus 0.632. So our question is, how much bigger is the tube? That's why we're subtracting from the value of the tube. Now, when I get ready to set up this subtraction, I'm going to set it up as we always do with any type of decimal problem. We start by lining up the decimal places, 0.560 and 0.632. I start going through my subtraction. I borrow 10 minus 2 is 8, 5 minus 3 is 2. And then I run into this particular situation. 5 minus 6. What does this tell me about this particular problem? Andrea?
It's going to be negative.
Yeah, that our answer should indeed be negative, which means that in terms of subtraction, we can't just flip these around to figure this out. That means this is completely wrong. When we set up subtractions, we have to make sure that the largest absolute value is on top. So here, after a leave change switch, the reason why we figured this out was wrong was that our larger absolute value is not on top. Okay, so we need to put the 0.632 on top of our subtraction, otherwise we can't even do the subtraction. Add my 0.560, and here we're going to subtract. 2 minus 0 is 2, 3 minus 6, that's going to require some borrowing. 13 minus 6 is 7, and 5 minus 5 is 0. Now, is that 0 important in this particular subtraction problem? Do I have to keep this 0? Why? Why do I have to keep this 0? Anthony?
I think because if you don't keep 0, you might think it's a whole number.
Yeah, so you might definitely think it's a whole number, or you might confuse it for 0.72 and 0.72 and 0.072. These are definitely not the same things, okay? So we definitely have to have that there. Now, so my answer here is 0.072, but, Mr. Ross, it's negative because we have to take the sign of the larger number. One of the great things about this is we can't do this subtraction properly unless our larger number is on top. So that's always going to identify for us which has our larger absolute value, which one we're going to take the sign from. So I'm going to take the sign from the one that was on top, which if we go back to the original problem was negative. All right, let's use some critical thinking skills. Now let's go back to what this actually means. Our question was, how much bigger is the tube? Negative 0.072. What does that actually mean in this particular situation? Use your brains. I got a negative answer to the question, how much bigger is the tube? What does that actually mean? Yang.
The dowel
Yeah, that means that the tube is not actually bigger. It means that the dowel rod is actually bigger. So in this particular case, that's what that negative means. That's one of those reasons why we have negatives. It's because they will explain things to us like that. Okay? So we can use positive and negative decimals. We can use like signs, add, different signs, subtract, take the sign of a larger number. The biggest problem that I see is not recognizing how to know which one is the quote-unquote larger number, which one has the larger absolute value. So when we're looking at decimals, I want you to take these 4 sets of decimals, and I want you to identify which one is the larger number. And while you're doing it, you should be thinking about, how did I know? What process can I use to make sure that I figure that out? Okay? Do me a favor with those 4 processes. Should be showing me with a 1 or a 2. Which of these first was larger? Okay, so I'm seeing a mixture of answers, which is interesting, because there's got to be some way to know for sure. I think one of the most common mistakes is to assume that the one that has the most decimal place values is the largest, but it's not. One person that I really liked how they showed their work was Mia. Mia, how did you show your work? How did you prove which one of these was larger? She lined them up by the decimal, 0, 0, 1, and 0, 0, 1. So what she recognizes is that if you work from left to right, you can always determine which one's larger. So 0, that's the same. 0, that's the same. The first place that she finds that they're different, which is right here, whichever one has the largest place value there, that's going to be the largest. That's definitely one way to do it. I would actually do it a little bit differently. I would line up my decimal place values. I would fill in all of my placeholders, and then basically I'd just pretend like there was no decimal place there, and I'd say which one of these is larger. If I think about these 2 numbers, this is 1 versus 10. Either way, as long as you're lining up those decimal place values, that's going to be the perfect way to always determine which one is larger. All right, show me 1 or 2 for the second set. These are indeed equal. Show me for the third one, 1 or 2. So this is a really easy one if you think about it in terms of money. This is 6.00, and I'm going to add an extra 0 there so I can compare 0, 4, 0. Add in all my place values. Once I add in all my place values, this is 6,000 versus 40 if I just pretend like the decimals aren't there. If I'm thinking about it the way Mia thought about it, I'm looking at the first place value on the left, and I'm already seeing that they're different, so I'm choosing the larger one, which is 6. And the last one, 1 or 2. You should be showing me a 1 or a 2 for the last set. So the work that I would want to see here is that we're lining up all those decimal places again, 203.21. Then I would fill in the 0, 0, zeros. The way I think about it is I think about it as if those decimal places aren't there anymore, and I think of this as 210,000 versus 203,000. The way Mia thinks about it, she goes place value by place value. She compares in this place value, they're the same. This is the first place value where they're different. And so she's going to choose the larger of those 2, which is again the 0.21. All right, so that's the most important and the most missed part, is not being able to recognize which one is the larger value. I can see from the answers in the room that you have no problem doing this, which means, Bijan, that when you're going through and you're doing the work on these particular problems, when you're trying to determine which one is the larger number, you just have to be focused on it and show your work. So looking at the first problem, we have Negative 0.203 minus 0.4023. Now, what is the first thing we should absolutely be doing with this problem? Because you know how I feel about it. Jacqueline. Leave, change, switch. After I leave, change, switch, I recognize this is like signs add. So here's a question. Does it actually really matter which one of these is the larger number? Oscar, why not? Because they're both negative, so whichever one is larger doesn't really matter. Our answer is still going to be negative. It also doesn't matter because when we add, it doesn't matter which one you put first because it's commutative. So 0.203 and 0.4023, just fill in my place value. It doesn't really matter. Addition is commutative. I can add these whichever one I want on top. Genesis. Yeah, so lining up the decimals when we add, super important. The great thing about lining up the decimals here when we do this addition, even if we really wanted to, since that's the first step of determining which is the larger number, we could actually really easily determine which one is the larger number since we've already lined them up anyway. But in this case, it doesn't really matter because they're both negative, so I get 0.6053. Next one, 0.93 minus 2. What is the first thing that we need to do here? Elmer. Leave, change, switch. Now I need to make sure that I know which one is the largest number because if I'm going to do subtraction, I need the largest absolute value on the top of my subtraction anyway. So for me, this one seems pretty obvious to me. I'm thinking about this as money. This is 2.00. That's going to be larger than my 0.93. And since my 2 is my larger number, I know my answer is going to be positive or negative. Everybody. Let me ask the question one more time because I know some people were ready to answer because they didn't hear the question the first time. Since I know that 2 is my larger absolute value, my answer is going to be positive or negative. That didn't really sound like everybody was involved there. So let's try this one more time. Looking at our addition here, we found by lining up the decimal points that 2 was the larger absolute values. When I look back at my original problem, that tells me this answer should be positive or negative. Still didn't hear everybody. So we're going to go through this question one more time. Perhaps if your teammate is not answering, you need to nudge them and make sure that they're listening to the question right now. All right. So looking at this problem, we decided that after lining up the decimal points that 2 had the larger absolute value. As I look back at my original problem, I see my 2 was negative, which means the answer to this particular problem should be positive or negative. Negative. That sounded much better. All right, so I know my answer is negative. Now I'm going to come over here. This was opposite sign subtract, so I'm going to do the subtraction. I need to borrow, but I don't have anything to borrow from, so I'm going to borrow over here first. 1 becomes 10. Now I can borrow. 9 becomes 10. 10 minus 3 is 7. 9 minus 9 is 0. 1 minus nothing, that is 1.07. I'm going to add that over to my negative over here. So again, one of the great things about this is by doing our work to figure out which one was the larger number, we also set up our subtraction. Look at the next one, 0.3103 minus 0.30456. Ricardo, what's the first thing we need to do here? Sorry, what was that? Leave, change, switch. Then we have to figure out which one is the bigger one because that will allow us to A, set up our subtraction correctly, and B, since this is opposite sign subtract, know which one is the sign for the larger number. So I'm going to start by lining them up. I'm going to get 0.30456 and 0.3103. And for me, I'm going to add on that extra 0, and I'm going to think about this as 31,000 versus 30,000, which tells me that my number that I've put on the bottom is indeed my lower number. So I know that this is my larger number, which means I know my answer is going to be over here positive. But because I set this up this way, I have to actually switch it back around to do the subtraction. Okay, so I have to flip around this so I can do my subtraction. So I'm going to put my 0.31030 on top because I know that's a larger number. You can't do subtraction with the larger absolute value on the bottom. I'll borrow here, gives me 10. It's 4. Need to borrow again, nothing to borrow from. So I'm going to borrow here first, then borrow from the 10. Nine minus 4 is 5. 0 minus 0 is 0. 3 minus 3 is 0. I get 0.00574. Now going back to the original problem, we knew this was opposite sign subtract, so we have to take the sign of the larger number. Everybody, the larger number was positive or negative? Positive. So our answer is positive or negative? Positive. All right, so we know our answer is positive. Now we have the last problem here, negative 0.432 plus 0.456. First thing we need to do is determine which one is the larger number. I can do that by lining up my decimals, 4.32, 0.456. I'm going to add my 0 here. Again, there are many different ways you can think about it. You can think about it in terms of as if the decimal were not there, or you could think about it the way that Mia does by checking place value by place value. Either way, I recognize which number is the larger. Somebody with a raised hand. Genesis. 4.32. And in the original problem, Sadie, 4.32 was positive or negative? Negative. So Naomi, that means our answer is going to be positive or negative? Negative. Good. So I'm going to go ahead and put that there. Then I'm going to do my subtraction. I'm going to get 3.864, again remembering that our answer was supposed to be negative. Put that over here by my negative sign that I had conveniently placed beforehand. So we need to move on to our key points before we end our lesson for today. There are a couple key points that I'm looking for. Nafisa, give me one. Leaf change switch. I think we've pretty much gathered that about all additions and subtractions. Naomi? Line up the decimal points. Why are we lining up the decimal points? There are actually two reasons why we line up the decimal points. What do we line up the decimal points for? Jacqueline? Yeah, line up decimal points to find the larger value. Ms. Ross. Boom. There you go. Like signs add. Different signs subtract. And as always, the most important and most likely missed part is take the sign of the larger number. All right. Wonderful, fantastic key points for today.